Okay, in this lecture we're going to talk about the quadratic formula. Now I'm not going to prove the quadratic formula. It does come from completing the square. And if you look at any college algebra textbook, you'll find the proof of it. So that's where it comes from, the process of completing the square. Alright, so the quadratic formula is a way that we can just always find the solution to the standard quadratic equation here, right? By identifying A, B and C, all we have to do is plug it in to this formula. And find out what the value of x is. Notice we have a plus or minus here, so we should get two answers, unless this part here, which we call the discriminant, and we'll talk about that in a later lecture. If that comes out to be 0, then we'll get one answer. Alright, so let's look at some examples. Alright, let's suppose I want to solve x squared plus 8x equals 5. Okay? Alright, so the first thing is, step 1, get it into standard form. So we'd have to subtract 5 from both sides. So what we'll get here is x squared plus 8x minus 5 equals 0. So this implies that a is equal to 1, b is equal to 8, and c is equal to negative 5. Right, that's simply by matching up the numbers in front. Okay? Right, so using the quadratic formula, x will be, notice negative b, so I'll need a negative 8 plus or minus b squared, which of course will be 8 squared, minus 4 times a, which is 1, times b, which is negative 5, all over 2a. So I'll end up with negative 8 plus or minus. Alright, so what do we have here? This will be 64. And we have 4 by 5 is 20, but we have negative 20, and a negative of a negative is a positive, over 2a, which of course is 2 times 1. So we end up with negative 8 plus or minus the square root of 84 over 2. Alright, now, can we simplify this 84? Is there a perfect square in 84? Well, let's have a look at some. Certainly we could go, let's do it here by 4s, couldn't we? So that would give us 21. So that looks pretty good. So 4 times 21 over 2, which will be negative 8 plus or minus, square root of 4 is 2, square root 21 over 2. Now, of course, now we have a factor of 2 in each one of these. So if I put a positive 2 here, then this will be a 4, a negative 4 actually, plus or minus the square root of 21 over 2. The 2's will cancel, so I'll be left with negative 4 plus or minus the square root of 21. Right, so that would be our solution. So our solution then in set form would be the set of negative 4 plus or minus the square root of 21. Right, now sometimes we can get complex results as well, so let's look at an example of that. Right, let's suppose that I want to find, well, we want to solve 4x squared equals 3x minus 5. So again, we get it in standard form. This becomes 4x squared minus 3x plus 5 equals 0. So that implies that a is equal to 4, b is equal to negative 3, and c is equal to 5. So by our quadratic formula, this will be, okay, so here we go, negative b, so it's to be the negative of negative 3, plus or minus the square root of negative 3 squared, minus 4 times a, in this case is 4, times by c, which was 5, all over 2 times a, which is 2 times 4. So this gives us 3 here, the negative of negative 3, plus or minus this will be the square root of 9 minus, let's have a look here, we have 20 times 4 is 80 by the look of it. Alright, over 8. So this will become 3 plus or minus the square root of negative 71 over 8, which will be 3 plus or minus the square root of negative 1 times 71 over 8, which is 3 plus or minus I root 71 over 8. And there's no other ways that we can actually simplify this, so our solution would be 3 plus or minus I root 71 over 8. Right, so that's how we do that. Alright, now a little aside here. What about cubics, for example? We know that if I have x cubed plus y cubed, we can always write this as x plus y by x squared minus xy plus y squared. We learnt that in earlier in the review. Or we could have x cubed minus y cubed, could be written as x take y by x squared plus xy plus y squared. And if you distribute these out, that's what you should get. So we can sometimes do that to find an answer to a cubic. So for example, let's suppose I want to solve x cubed minus 125 equals 0. Well, this implies what I have is x cubed minus 5 cubed equals 0. So using this particular form here, what I would have is that x cubed minus 125 would in fact be x take 5 by x squared multiply x times y, so that would be plus 5x. And in this case would be plus y squared, which would be 25. Alright, and that's what's equal to 0. Now of course we have a quadratic here, right, and so we could solve this quadratic by using the quadratic formula. So that would mean I'd have x is equal to here, b is 5, so it's negative 5 plus or minus the square root of 5 squared is 25 minus 4a, which is 1, and c would be 25, all over 2a, which is 2 times 1. So notice that this comes out to be negative 5 plus or minus the square root of. Now notice that this is a 1 here, so 4 25s are 100, and so what we end up with here would be 25 minus 100 minus 75 over 2. And so this would be negative 5 plus or minus. Now we have a square, so we have an I in here and a 3 times 25, so this would be a 5i square root 3 over 2. Alright, so in this case here what we have then is we've got the zero factor property that tells me, so here's our solution. So it tells me that x minus 5 is equal to 0 or this is equal to 0. So x minus 5 being 0 means that x is equal to 5. Okay. And x squared plus 5x plus 25 equals 0 is when we have negative 5. Alright, we have negative 5 plus or minus 5i root 3 over 2. And so our solution then would in fact be and the 5, okay, and of course the negative 5 plus or minus 5i root 3 all over 2, and that would be our solution. So that's one way we can deal with the addition of cubed numbers or the subtraction of cubed numbers. And notice that we did have to apply the quadratic formula to this part here. Okay.